Good day, everyone, and welcome to this Lightbend interactive demo for June 16th, 2020, titled Visualizing Akka Cluster Node Lifecycles. My name is Oliver White, Chief Storyteller and MC at Lightbend, and joining me is my Akka partner and mentor, Hugh McKee. You may have seen some Akka-focused webinars by Hugh, who is our developer advocate, previously Globetrotting conference speaker, O'Reilly author, and former aeronautics engineer. So today's session departs from our normal webinar style. As we explain on the sign-up page, you are welcome to perform the setup and demo along with Hugh and me if you like. You only need to have Java 8 or higher, Maven, and Git installed, plus the link to the GitHub project, which I am now putting into the GoToWebinar chat window. So this is one of several points where we will stop and check in with those interested in coding along with us today. All right, let me pop this into the chat window. There you go. I'm now going to see who among us is actually interested in doing this with us, so we'll know how to engage with you all later. So if you're planning to do the demo with us, have you downloaded the project? Yes, you have. No, but now you want to, so you can go to that GitHub link I just shared. Or no, you're just going to watch with us today, which is probably a way of getting the most out of this presentation, although you will be able to watch the video after we share it with you. So if you've heard a little bit about Akka Cluster before, then you know that it provides a really powerful way to scale high-performance microservices and preserve data consistency in cloud-native applications. But until now, much of this power is expressed behind the scenes, and it's a little unclear about some of the magic that Akka Cluster will work. So in today's hands-on session with Hugh, you'll be able to install a very simple dashboard to visualize, deploy, and interact with Akka Cluster nodes and their life cycles. We'll start with an intro to Akka Cluster and the browser dashboard that we'll be using today. As we mentioned, you can install the project directly in order to interact with the dashboard during the live session on your own side. I will note that if you are planning on watching Hugh and performing the demo on your own side, you might have a little bit of bandwidth challenge, and your attention will most likely be shared between the two things. We'll continue to look deeper into the cluster dashboard, the CLI commands, and some different states of Akka nodes. Then we'll go over the node lifecycle interaction and what it looks like when nodes leave, join, or are forcibly removed from the cluster or become unreachable due to network problems. This is the fun part where you can write to us in the chat window, or rather the questions tab of the GoToWebinar control panel, and you can give us some suggestions for what Hugh should do with the cluster, such as remove these nodes, start up these nodes, etc. We'll also have some time at the end for the Q&A as well. All right, thank you for sharing your feedback in that poll. As always, today's webinar is made possible only by Lightbend's hundreds of happy customers that benefit from expert support, technology enhancements, and observability and monitoring, such as our customer HPE. They have openings for folks working with Akka, Spark, Kubernetes, and Scala for their data services projects. You can find out more about these positions at careers.hpe.com. Today's webinar is being recorded, and you'll be able to get access to it later next week. If you have questions for Hugh, feel free to add them to the control panel in the questions tab, and we'll see if we can get around to them in the Q&A part of today's session. And if you are an existing Lightbend customer, then you are aware that you can reach out directly to our expert engineers through the customer portal and ask any of your additional technical questions, what-ifs, how-tos, and best practices. All right, that is it from me. So let's hand it over to Hugh McKee. Hugh, always a pleasure to have you back, sir.
You know, it's great to be back, even though I'm not globetrotting anymore, but at least for the time being. But yeah, I've been looking forward to this. This demo is fun, or at least that was my intent, was to make something that was fun with a visual component to it. So as you mentioned, we're really just we could try and make this interactive. This is a bit of an experiment on our side to try this on a webinar. But I'm going to go through a little bit of the intro and setup of the project, and then we'll get into actually using the project and playing around with it. And then after that, in the third part, we'll get more serious about actually doing things to the cluster, and then wrap up with a Q&A. Also, as Oliver mentioned, these are the requirements. If you're interested, you can grab the GitHub project, clone it and build it and run it on your own. So everything that you need to run it is contained in this pretty simple Java Maven Akka project. So let's go into the demo. So this is a view of the dashboard running on my laptop. And I started this up. What it's showing is an Akka cluster that's running. So things are running right now, but what I want to do is I'm going to stop this cluster and we'll start from scratch. So there's a set of scripts that are provided with the project for helping with controlling this cluster. So I'm going to stop this cluster, and we should see in the dashboard, it's showing things are happening in the cluster. It's showing nodes are leaving the cluster. This is a kind of a contrived demo in that it run a cluster of up to 9 nodes, all running on your desktop. So this cluster is down. So I'm going to close this tab for the dashboard, and then I'm going to remove this project from my directory. And then I'm going to clone the project again, and then go into that directory, do a Maven clean package. So I just did a git clone, cd into the directory, Maven clean package. It builds the project. Everything should get set up. And then once it's all built, it has a runnable jar. But in this project, there are a set of scripts. And so I tried to add these scripts to this project to make it easy to play with this cluster demo. The main script is called Akka, and there's a help to it. So the help shows that there's commands related to controlling things at the cluster level, like starting and stopping the cluster. There's other commands for controlling things at node levels, so starting or stopping individual nodes. And then there's another set of commands that we won't be going to here today, but are concentrating on doing things at the network level, which is a way to kind of simulate network partitions, broken network segments and so on. I'm doing a series of videos off this project as well, and there'll be some videos we'll be doing, save with split brain resolver and so on, using some of these commands. But to start the cluster, it's pretty simple. You just do an Akka cluster start, and by default, it'll run 9 nodes. If you could say Akka cluster start 1 through 9. If you say 1, it'll start a cluster of 1 node. If you say 5, it'll start a cluster of 5 nodes. Now these nodes aren't really doing anything other than that they're running. But what's happened here is this cluster's started up and it's up and running. So now we should be able to bring up the dashboard. And that's done with a command, just Akka cluster dashboard. And what we should see is a tab pop up in a browser, and the project, it's showing the cluster that's running. So this dashboard is just, it's nothing official. It's just something I wrote. It's in JavaScript. It's just for this demo. And the thing I wanted to be able to do with this, though, is have something that was showing things happening in a cluster visually while it's happening, instead of looking at a bunch of log files. I've been using Akka for a while now, and I spent years trolling through log files trying to figure out what's happening in the cluster. And I always dreamed of having some kind of visualization like this, and I finally got an opportunity to do it. So that's really all it takes to get to the point where you've got this demo cluster running, you've got the dashboard up, and you can start playing with the scripts. So I think, Oliver, this is a good point to go into and see if people have been able to do it, things like that.
Yeah, that's a good point, Hugh. So about half of our audience is either ready to go or was interested in getting set up in the last 5 or 6 minutes. Let's just take a quick poll to figure out how everything's looking. If you are interested in continuing with the project today, have you been able to successfully install that and get to the point where Hugh is now, or rather, at least prior to his browser? Okay, I'll just leave this open for another few seconds. Looks like the majority of people are in the yes column, although no is creeping up a little bit.
I hope not too many people have problems.
All right. Well, we will be able to show you in a little bit more detail what's going on if you've had a little bit of a trip up getting set up.
Yeah,
okay, let's get back to Hugh then. So the majority of people, it's 61% yes, 39% no.
Oh, very nice.
So that's, if this were a vote, this would be a celebration.
Yeah, cool, because this is the intent of this project, is that you can grab the project, download it, start playing with it, experiment. You have questions about, well, what happens in the Akka cluster when these things happen? And you can try those things by basically being able to start up a cluster, starting and stopping nodes and different things like that. So I'm delighted that a number of you were able to get the project working. I tried to make it as lightweight and kind of low friction as possible. Awesome.
Yeah,
and
so, for anybody who wasn't able to get set up now, we have plenty of content that you can check out after this session, so that you can do it on your own at your own pace and make sure you get everything done well.
Cool. So let me explain a little bit about what's happening in the dashboard. You can see on the right, there's kind of a 3x3 grid, and that represents the 9 nodes that are running in the cluster. And then on the left, it's showing one node. And the thing on the left is showing the node that's currently the leader. And I'll explain what the leader is in a few minutes. But the thing that's pretty interesting on the right is that each of these little panels is showing what each of those nodes thinks the rest of the cluster looks like. So what's happening is the JavaScript in this browser tab is polling the nodes at a fairly, I think it's every 200 milliseconds or something, and it's sending out like 9 individual HTTP requests to all 9 of these nodes, and it's asking, tell me what you think the cluster looks like from your perspective. And this is really what's happening in Akka. We've got 9 JVMs are running. These JVMs are running Akka. Akka has formed itself into a cluster. These nodes in the Akka cluster are talking to each other over the network, and they're trying to work out each one of them individually to come to a conclusion or consensus on what does a cluster look like. So this is what I really wanted to try and achieve with this dashboard, is that as things happen in the cluster, we can see what each of the nodes thinks the cluster looks like as things start to change. And I'll give you an example that, say I'm going to stop a couple of nodes. So I need to go into this directory, and then I'm going to stop.
Hugh, can I pop in real quick? Is the localhost 9551 going to be the same for everybody working on this project right now?
Yeah, of course it's configurable, but you'd have to change it, but yeah, it is.
Okay. There was a question that we got stuck at the browser window, so.
Yeah, okay.
Just checking in. Okay, thanks.
Yeah, and actually each node has an HTTP server running on it. So dealing with all the ports here was one of the things that this demo does. So you can hit the console on 9551 or 9552 for node 2, 9553, all the way through 9559. So if 9551 isn't working for you, you might try one of those other ports. So I'm going to stop nodes 1 and 6. So the script, I'm in the project, /akka node stop 1 6. And when I do that, you can see nodes 1 and 6, they change state, and then you can see the nodes go away. But if you were watching, you could also see that it didn't happen simultaneously in every panel in the screen here, in the dashboard. And that's because while all that was happening, the browser was polling each of the nodes and was asking, what do you think the cluster looks like at this moment? And we were seeing kind of the intermittent changes that were occurring as they happened on each node. So now what we're seeing is that node 1 is stopped, so it's grayed out in the on the top left of the right side, this 3x3 grid. But if you look at node 2, which is running on port 2552, it's showing its view of what the cluster looks like. So it's got its own little map of, well, what there were 9 nodes running in the cluster. Now there's 2 that have stopped. And the same thing is true for node 3 all the way through to node 9, except for node 6, which of course is also down. Also notice on the left that now which node is looking at is now 2552. And the reason for this is that the node that's currently designated as the leader has moved from 2551, node 1, to 2552, node 2. The leader in an Akka cluster has a very specific role. It's not a master. Often when you hear about clusters, you hear about clusters having a master node, and there's worker nodes, that type of thing. Well, here in this case, there's a leader, and the leader's role is really only to make a decision across the cluster when it's okay for new nodes joining the cluster to go to a fully up state, or when nodes should be declared as having left the cluster. So that's all the leader does. Now, the leader is any node in the cluster can be the leader. And in fact, the strategy that Akka Cluster uses on deciding which node is currently the leader is simply which node has the lowest IP and port. So since all 9 of these, are actually 7 nodes that are running now, they're all running on localhost 127.0.0.1. So the decision is made by what port they're running on. So now the leader's on the lowest port. There's also a concept of oldest. That's what this big O is showing. And the oldest is the node where cluster singleton actors run. One of the features of Akka Cluster is it's called Akka Cluster singletons, and what it is that you can have an actor or set of actors that you only want to have one instance of that actor running anywhere in the cluster at any point in time. And the strategy for that is that the cluster singleton actors run on the oldest node. The reason why I think the Akka team used that strategy is that given it's the oldest node, it's the node that survived the longest, so maybe it's one of the more stable nodes, where you don't have to keep moving the singleton around. So in any case, that's kind of a quick tour. So the whole situation is that you can stop nodes, you can start nodes. I'm going to show, say, killing a node. So there's a difference between killing a node and stopping a node. So I killed node 8, and what I just did was just did a kill -9 on the process. So what we see here is that now the dashboard gets a little bit more interesting in that we've got red, which always kind of raises the alarm, what's wrong? So in this case, yeah, there is something wrong. We had a node that was there a moment ago, and all the other nodes were aware of it because they were talking to it. They're it's called gossiping with each other to keep track of each other. And all of a sudden, node 8 stopped responding. So independently, each one of the other nodes, the other 6 nodes that are still running, recognize that their messages to node 8 were not responded to. So we got to the situation where the cluster comes to kind of an agreement that, oh, node 8 is unreachable. Now, all these nodes, all they know is node 8 is unreachable. We don't know if node 8 is down. We don't know if node 8 is still running, but the network between node 8 and the rest of the cluster is broken. We don't know. All we know is from the perspective of the nodes that are green is that they can't talk to node 8 anymore. So yeah, that's another situation. So the difference is that when I stopped nodes 1 and 6, that was an orderly shutdown. Those clusters, those nodes actually started the shutdown process where they went and they notified Akka and said, hey, I'm leaving the cluster. So that was communicated over the rest of the network to the rest of the nodes in the cluster, say, node 1's leaving. And it was an orderly departure of that node from the cluster. Node 6 did the same thing. Node 8 just stopped communicating all of a sudden. So there's a big difference between an orderly shutdown, an orderly stop versus an abrupt, I can't talk to this node anymore. Oliver, I want to go into, really kind of get into some of the commands and so on. Did you want to ask another question at this point, or
well, no, the next question will be to elicit some responses from our audience regarding what should Hugh do to the cluster. But I think, do you want to walk through some more node lifecycle stuff before we get to that?
Yeah, so let me walk through, and then if anybody has a question, well, what would happen if you did this, then feel free to post it, and we'll see if we can give it a try. So
we have a question incoming, and I think it's quite relevant. So the leader node is now 2552, but we see that the L is in red. Why is that happening?
Good, thank you, excellent. I love visualizations. The reason why it's red is that the leader is in a state where it cannot make the decisions it's really there to make. Meaning that if a new node joined a cluster, it wouldn't be able to bring it to an up state. If nodes were leaving the cluster, it wouldn't be able to change the node state for the entire cluster to removed. So that's why when this happens, when there's an unreachable node on the dashboard, it's showing that the leader is red. It's really kind of in distress. It can't do what it's supposed to do. And perfect question, because the next thing I wanted to show is that if I start up nodes 1 and 6 again, and we'll see what happens here. So they're starting up, and you can see that they go to weekly up very quickly, but then they stay there. They're stuck. And this is an example of the node life cycles, where nodes can go through different states. And there's actually a really good diagram in the Akka documentation. I should have brought that up before the webinar. I didn't do it. Sorry about that. I don't want to spend the time digging for it, but it's not too hard to find. But there's a nice kind of visual diagram that shows the life cycle diagram. So, but it's basically things like, a node. The ideal state of a node is that it's an up state. The other opposite is that it's removed. It's gone. It's not part of the cluster anymore, which is what we saw a moment ago when node 1 and 6 were not running. And in between there, though, there's kind of transition states. So like a node, when it first starts up, it's in a joining state, a starting state, a joining state, and then it goes to an up state. When a node is leaving the cluster, it goes through a leaving state, an exiting state, and then removed, and it's gone. So in the dashboard, that's what I'm showing here, is that each node is showing what state is it currently in from the cluster's perspective. And again, on the right, which each one of these little panels, if I go to like zoom in on 2552, it's the same thing. It's showing, we're all seeing the same thing, but this is data that's coming straight from node 2. And it's the same in every one of these 9 panels, is that the map of what is the state of the cluster was retrieved from that node in the cluster. The browser actually reached out to that particular node and said, what does the cluster look like to you? So like node 4 here, the browser asked node 4 directly, what's the cluster look like to you? And because the node 8 is in an unreachable state, the leader cannot change the move nodes that are joining from starting to an up state. So it has to put them into a weekly up state, which is significant because, like with cluster sharding, for example, which is a really nice, powerful feature of Akka Cluster, cluster sharding won't use nodes unless they're in an up state. So even though this node's up and running, cluster sharding won't use it because the cluster's in a weird state right now because we have one or more unreachable nodes. So I'm going to do this manually, but what we can do is we can down that node. So there's another script for this, Akka node down, and then there's an option. It's called via. So I'm saying Akka node down via node 1 down node 8. That's what this command is saying. The reason for the via is that this message has to be sent to one of the running nodes. If node 1 wasn't up, I wouldn't be able to send it to it. So this script needs to be able to know which node it should talk to send the message in to say, tell some node in the cluster to say down node 8. I can really send this message to any node in the cluster, but right now I'm just going to do it via node 1. So the down, what we should see here is that right away you saw those 2 nodes that were in a weekly up state go to an up state because the leader was happy now because it was able to see that node 8 is down and it's no longer in an unreachable state, so that the leader goes back into a happy state and everything's good. So Hugh,
Hugh, if I just want to, this is pretty awesome stuff, and a lot of people are writing and saying it's very cool. I've seen this before, but I wanted to just take a minute to slow down, and because everything happens really fast in this. So what was going on before was that node 8 was unreachable, and the cluster didn't know what to do with it and wasn't able to do anything with it automatically because this is a manual-based demo. So that caused the leader node to go into a state of, let's say, red or emergency, saying there's a problem in the cluster altogether. So therefore, as the leader node, I'm not going to authorize nodes 1 and 6 to join the cluster because we're in a state of having an issue.
Right.
And then once the problematic node was, let's say, handled by the cluster, then everything else could set itself back up again. And now we see that the leader has moved over to node 1, which is where it was originally because it's based on node address, and it's no longer red.
Right.
Did I get that right?
Yep.
Sweet. All right, I'm finally learning this. Great. It only took about 9 hours of me watching this, but great. So thank you. Thank you for letting me answer a few questions that were in the chat, and hopefully we can move on now. So thanks.
Yeah, and thanks for slowing me down, because you're right. There is a lot going on here, and this is also, again, why the dashboard, I think, is fun, because we can see it, and then given that so many were able to download it, get it running, you can experiment with things by yourself. And I learned a lot, so what would happen if I did this, those types of things. And so it's a great learning tool to be able to play with these things. The thing I want to show is also, let me start up node 8 again. Let's get back the cluster back to running 9 nodes. So see, it shows joining, and then boom, it's up. And you can kind of see it propagate through the other nodes in the cluster. So it's not, it's not like speed of light. There's a little bit of latency, not too much, but it's like within a second or so, and it's across the cluster. Now, of course, everything's running on my laptop, but it's pretty much the same behavior when you're running across, a real network where you've got nodes that are distributed, say in pods in Kubernetes, or in real machines or virtual machines or whatever, distributed across the network. I want to show, I'm going to just do the down again, just to show you that it does show, let me down 5. That's what the oldest is at right now. So let me down 5. So that there's a different color. It's just showing a different color. It's showing it's going down. You might show unreachable for a moment, but then it should all clear up. There we go. So we watched it. So in that case, the down message was sent to a running node. That node got it and goes, oh, it's time for me to leave. I don't know why, but I'm told to get out. So that node got out, the JVM shuts down, and we saw the change propagate through the cluster. So it's the same kind of thing. You can explore or play with what happens when you down a node. And if you look at these scripts, they're just bash scripts that I'm running, and I've just tried to simplify, the commands, what I have to type in to make these things happen. That's all these scripts are doing, and all the source, of course, to the scripts is in the project. So we start up 5 again. So we see it joining, and then it goes up, and then we can see it kind of propagate through the cluster again. Now, another thing I want to show is this is a relatively simple cluster in that it's still using seed nodes. And I show which nodes are the seed nodes in the dashboard. So 2551, node 1, and node 2, 2552, are currently configured as the seed nodes. So what are seed nodes? Well, what happens is that as each node starts up, it looks at how is it configured. And it looks at things like, well, where am I running on the network? What host am I on? What port am I on? And it also looks at its configuration and settings. And it's one of the most important things that the node needs to figure out quickly is, well, how do I find other nodes that may or may not be running in this cluster right now? So for nodes 1 and 2, when they start up, they look and they see, oh, okay, I'm up, say let's go with 2551. It starts up, it looks at the configuration, it goes, oh, okay, I'm up, and oh, I happen to be a seed node. And 2552 does the same thing and happen to be the seed node. So they know that they start checking on each other. 2551 starts pinging 2552, are you there? Are you there? I'd like to talk to you. You're another seed node. We should make sure we're both running as quickly as possible. 2552 does the same thing. So, and there's logging that I've added to this project that you can see if you look at the logs that shows some of these state changes that are occurring as cluster node state changes occur. They're getting logged out by an actor that's actually part of this project. But in any case, you can kind of see that these two start to collaborate with each other. But it's different for the other nodes, the non-seed nodes. So what they do is when they start up, so let's say like 2558, when it started up, it starts running and it sees, oh, I'm not a seed node. So for me to join the cluster, I need to talk to one of the seed nodes so that I can tell that node I'd like to join the cluster. So 2558 will start up, it gets this configuration, and then it starts trying to communicate with 2551. If 2551 is not responding, it'll try 2552. And it'll keep trying either one of those two nodes until one of them responds and says, hey, yep, I hear you. And they chat back and forth with each other. And then the leader, which is currently running at 2551, goes, all right, everything looks good, 2558, you're good to join the cluster. So 2558 comes up. And again, you can see this in the log. are the logs, because there's 9 logs here. On the dashboard, we can kind of see it all happening in real time. So that's kind of what's happening now. That the cluster bootstrap process is different depending on the environment. So from one extreme to another, this extreme is really simple, with all the nodes run on fixed IPs and ports, which is really not practical in this day and age. So the other extreme is that we're running in a Kubernetes environment where Akka really loves to run. But the challenge was, well, how do the nodes find each other in an environment where we have no idea what the IPs are going to be where these things are going to be running in the network inside of Kubernetes? Well, the cool thing is that there's a feature called Akka Cluster Bootstrap that does all the work for us. And it's just a little bit of configuration. And basically what we tell Akka is that when each node joins up, it makes a API call to Kubernetes and asks it, give me the list of other nodes that look like me or like me that are currently running in the cluster. And it uses the return from that API call to basically as the seeds, for nodes to start to discover each other and then talk to each other and form themselves into a cluster. There's a few other different Akka Cluster Bootstrap options, but the ones that we see are kind of the most popular these days. We're seeing a lot of movement to Kubernetes. And there's different strategies between. You can look at the documentation. What else can we do? Any questions on try something? I know some.
Oh yeah, there's a lot of those. Maybe it would make sense. So actually, there's a question that just came in that's pertinent to this screen right now. So if node 7, 2557 is the oldest node, is it not a seed node?
Good question. Yeah, there's a difference between the oldest and leader will move around depending on things happening in the cluster. With the seed nodes, they're fixed, which I don't know if we have enough time to go into it today, but this is something that you can experiment with. Is if you try, like if I stopped, say, the first 3 nodes, 1, 2, and 3, so both seed nodes are down, and then I try and restart node 3. Now the other 6 are still running, but if I try and start node 3 when 2551 and 2552 are down, that node's not going to be able to join the cluster.
Do you want to give that a shot right now? Or is that could that break something?
Well, I mean, you can't break anything. I mean, you can't break anything. The worst case scenario is you're going to have to shut the whole cluster down and restart it. The
Okay.
situation is that, well, let's do it. Let's just do it. What the heck?
Yeah, what the heck?
So 1, 2, and 3.
And depending on what happens here, it may lead directly into another question. Okay, so we just saw that the leader moved to the next lowest node address, which is 2554.
Right. So
and the command there was down or stop.
Stop.
Okay.
Akka node stop, and then
So if we use down, then that will result in an unreachable state for that node. Is that correct?
No, down is an orderly shutdown. So down and stop are somewhat synonymous. It's just down is typically used for a node that maybe is in trouble or gone or unreachable, and you need to tell the rest of the cluster, all right, we're done with that node, let's down it. So it's a decision that's made not by that particular node, it's a decision that's made by other nodes in the cluster or manually, or by something like the split brain resolver to tell the rest of the cluster, this node is no longer part of the cluster, and let's just clean it up. Let's just get rid of it. We're not going to talk to it anymore. Now, if that node gets a down, it's going to stop itself. That's just part of the way the code works. But stop, on the other hand, is where the JVM was told to stop. which before it actually completely shuts down, it goes through an early shutdown process, and there's a whole shutdown sequence that it can occur within Akka, where it goes through and says, yep, I'm going to be shutting down my JVM, but before I do that, I want to let you guys know I'm out of here. So it sends a message over the network, so the rest of the cluster knows, and then they kind of go through a little bit of talking back and forth, and then everybody's happy, and that node's gone. So if I try, go ahead, Jim.
No, thanks.
All right, so let's try and start node 3. But nothing's going to happen, right? Node 3 might come up. I don't even know. I'd have to look at the logs to see what happens in this kind of situation. But it's not going to be able to do anything because it can't join the cluster because those 2 C nodes are gone. So if I try and start 1 and 2, there's 1, there's 2. Oh, there's 3. But look what's happened here. This is the weird part.
Then now we have a split brain.
Yes. Because, and this is what's really fun about, you think about what's going on here, is that I started node 3, it was running, and it was trying to talk to 1 or 2, but nothing happened. So then, and it was a while before I tried to run or started up 1 and 2. 1 and 2 came up. They go, okay, yeah, I know how to talk. 1 goes to 2, 2 goes to 1. They start talking to each other, and then 3 goes, hey, I want to join the party. And they go, oh yeah, fine, cool, yeah, you can join the party. But the other 6 nodes, which are still running, aren't communicating with those nodes. They're not trying to talk to nodes 1, 2, or 3 anymore. So you can see there's this discrepancy. There's you can see the split brain. If you think of those 9 nodes as the brain, but the bottom 6 nodes, their picture of what the cluster looks like is just the 6 bottom nodes, not the top 3 nodes. If you look on the other side of the split, the top 3 nodes can see each other, but they can't see the bottom. So as an experiment, let me try, I'll stop one of the nodes on the bottom. I've never gone this far. Let's just try this.
Yeah. I should have mentioned that we're getting suggestions to do some pretty wild stuff here. So it wasn't in the normal demo or use case that we were imagining. So this is pretty much an adventure for us. Okay, so we do see another exiting. There's a question about a brown tone, a brown toned color used, and I actually had missed it before, but now I realize that it's exiting. Yeah. So. I know a lot of people are colorblind, which what can you do? Or they're finding out that they're colorblind during this presentation itself. Yeah.
So I hope the contrast here is at least showing things are running or not running, and then of course there's text in there. It's a little bit small, but so you can see I stopped node 5. The other 6 nodes saw it. So what do you think is going to happen if I start node 5?
You blow up the internet?
No.
Oh, look at that.
Yeah, see?
Okay.
So we definitely have a split area.
But so node 5 is now siding with the smaller cluster in the partition.
Right, because it started up, it's configured to go.
Yeah, because it's relying on the seed nodes.
Yep.
Interesting. I haven't seen us do this one before.
Yeah. Yeah, none of the videos I've done did this. I play with it.
Well, to be fair, if this was a video, people would be going, "What the hell?"
Yeah. So to fix this, I mean, we got a split, right? So what does a cluster do here? And this is the whole dilemma of a partition. Every cluster, like Cassandra, all these other really cool things that are out there that we use all the time that run in a cloud environment, run in a cluster, have this problem. What happens when you get network partitions or some kind of partition? You've got to have a strategy for resolving it. So in this case, I don't have split brain resolver enabled on this project. I've got another version of this project. It's a totally separate GitHub project, where it is enabled, and I'll be doing a video of that soon. But here I wanted to kind of be able to manually go through what would the split brain resolver have to do to deal with this. So we've got a 5-4 split here, right? And but also the problem is we've got a split where we've got the hard-coded seed nodes, which isn't great, but it's a simple project. There's other ways to deal with that, but that's the way this project works. But in any case, we've got a situation we can't run like this, because if we were running an application that was using cluster sharding, we'd have cluster sharding running on basically both of these two independent clusters running the same stuff, and which isn't good. This is not the way the cluster is supposed to run. So the solution is that we really need to have something that can resolve the split. So here, we really need to stop, say, 4, 6, 7, 8, 9. Watch them go away. And then I'll start them back up. 4, 6, 7, 8, 9.
So Hugh, there's a couple questions out there saying that we all understand that this is a manually driven demo, which is why it's so lightweight and kind of easy to even run. But in a real life production cluster, do we have tooling in place that would allow automatic healing of the cluster, for example, in a split brain scenario, or a node faces some difficulties and so on? What solutions are out there for kind of automatically taking care of this stuff?
The cool thing is that now there's a split brain resolver, and it's part of the open source. There's also other split brain resolvers out there that aren't from Lightbend, are from the Akka team, that other folks have been using as well. And they have similar design goals, and what they do. They're basically doing the same thing. So the beauty of those things is that they just automate this. That this whole process of dealing with weird behaviors of, say, unreachable nodes or network partitions or whatever is just automatically handled by the split brain resolver. That's the key player in dealing with this. On top of that, and this is what's really exciting about running in a Kubernetes environment for Akka, is that in a Kubernetes environment, we've basically, what you tell Kubernetes is, I want to run a cluster, and like in this example, I want to run a cluster with 9 nodes. And so that's something that Kubernetes itself knows. And then say, but there's a network partition or something wrong with the network in Kubernetes, and a bunch of the nodes are cut off from each other. So they can't talk to each other. Now, Kubernetes may or may not know about this, but Akka will know about it, because all, like these 9 nodes, say the bottom 3, say node 6, 7, 8, and 9 are cut off from 1, 2, 3, 4, 5. There's a network partition. And the split brain resolver will go, all right, nodes 6, 7, 8, and 9, the top group, which is the majority, will say the bottom group, we're gonna down them, meaning that we're gonna say you're no longer part of the cluster. On the other side of the partition, nodes 6, 7, 8, 9 are still running. They also see that they can't talk to 1, 2, 3, or 5. And they go, oh, we're the minority of the cluster. We're going to shut ourselves down. So it's like, everybody in this call, we're all in a cluster, and all of a sudden I can't talk to you guys. My internet goes down. So you guys go, at some point you go, well, is Hugh back? And maybe he'll come back in a moment. And then you wait a bit and you go, well, Hugh's not coming back. We're going to down him. He's out of the call, right? I'm sitting there doing the same thing and going, I can't get back. I can't get back. I can't keep participating in meetings. So I'm going to say, well, I'm out of the meeting, but I have to make that decision on my own, and you guys have to make that decision on your own. That's kind of what the split brain resolver is doing. But then when Kubernetes sees that those 4 nodes shut themselves down, it goes, oh, this application said it's supposed to be running on 9 pods, which are basically, I kind of think of them as placed, where nodes run almost like virtual machines, but they're not. In any case, Kubernetes goes, oh, I need to start up 4 new pods to replace the 4 pods that stopped. So Kubernetes will start up those pods. Those pods will start up. They'll go and they'll go through the process and join the cluster. So the beauty of running an environment like this is that there's a symbiotic relationship between what's happening in Akka, kind of inside the nodes, versus what's happening in Kubernetes, which is kind of outside the nodes. Kubernetes is running the processes. Akka is running stuff inside the processes, and it works beautifully. The orchestration environment that we get with Kubernetes is something that Akka has been winning for since Akka Cluster first saw the light of day around, I think it was around 2013 or 14. And it's this beautiful environment for that.
Okay. So there's a lot of really positive comments here. I'm looking through questions as well. Here's one that came in earlier, and I like this, and I don't know if we've gone through this scenario before. So let's check it out. So before, you had a situation where there was an unreachable node and the leader was in a red state. What happens if we put the leader back in a red state and you kill the node with a leader? You kill that node, and how is leader selection? How does leader selection work from there?
Okay, so let's do that. I'm gonna do it real quick. We'll kill 8 again. Right? We should see 8 go away and then 8 go red and the leader go red, right?
So in real life, this is, for example, this is a network partition, for example, on a single node.
It could be a network partition. It could be that the hardware that this process is running on went down. It could be any issue that interrupts the processing of that node, that JV.
Okay.
So now the leader is red, it's on 2551. So should I stop or kill node 2551? I guess it doesn't matter, right?
Well, so if you stop node 1, then, well, let's try stopping it first and see what happens, because that's an orderly shutdown compared to a kill.
Right.
So let's stop it first. So we see it's in the leaving state. It's funny. I thought I saw exiting as well.
Yeah, you might see that momentarily.
Okay.
Now,
so exiting and leaving are actually separate states.
Right.
Okay.
But notice what happened. It sat there for a while in a leaving state, and then now node 1 shows unreachable. But guess the leader has moved to node 2, the next lowest IP import. Right. So
why is it unreachable rather than, because if we didn't kill it and we stopped it, that should allow it to shut down in an orderly way?
It should, but the leader's job is to also change the state from running, leaving, exiting to removed, and it can't do that when it's in this unhappy state, because there's another node that's unreachable.
Okay.
So
we saw that if we were to kill node 1, if we were to go back and then kill node 1, we would see the same situation.
Yeah, it really doesn't make any difference, because, and I don't know if I have the time to do it, but if I down node 8, right, not node 1 and 8, I'm just going to down 8 and watch what happens. I think node 1 should go away as well, and the leader should become happy. Oops, I said via 1, and 1's not there. I need to do it via 2. There you go.
Well, if anything, this really just proves that this dashboard is truly functional.
Yeah,
It's not smoke and mirrors. We promise.
there goes. So,
Okay.
so what I just downed 8, and then the leader goes, oh, the unreachable guy is gone. So now I'm not in a bad state anymore. So now I can finish removing node 1. So node 1 is now also, officially out of the cluster. I didn't down 1 and 8. I just downed 8. So there you go.
Okay. Let's see what else we have in here. So there was a question about what happens when we have excuse the sirens in the background. What happens when we have an intermittent connection to a single node? For example, if we disconnect one and then reconnect it without starting, that was kind of how the question was phrased. I'm not sure how we would translate that into the demo
It's a really
terminology.
good question. Yeah, it's a really good question.
I guess the point is a flickering node.
Yeah,
the light bulb is kind of on and off.
It's a matter of how long do you wait before you make a decision. And excuse me, in a situation like that, say the network is flaky between to a certain node, and excuse me 1 minute. So it goes unreachable for a moment, but then it comes back online and it starts talking again. Well, if it hasn't reached a certain timeout threshold for the rest of the nodes in a cluster, it'll come back to an up state.
Okay, gotcha.
So there's a little bit of a grace period there, and that's why it shows unreachable, because really from the perspective of the other nodes that are still running in the cluster, all they know is they can't talk to it. They don't know if it's still running. They don't know if it'll be back in a moment. They don't know if the network is kind of flaky. And I saw that with a customer I worked with through most of 2018, where they were in a Kubernetes environment. There was some really strange thing going on in their network. It was just driving us crazy. We finally discovered it, but it was a real intermittent thing, and it was just it was quite interesting. But that's the kind of situation. But at some point, the cluster needs to make a decision to cut our losses and move on, right? So it'll wait for a bit, but then at some point it'll make a decision like, all right, it's unreachable. I don't care if it comes back; it's unreachable. Or like when the split brain resolver is running, it'll make a decision, say you're out. You're gone. Now the node can start up again, but it's from the perspective of the cluster, it's a new node. Because every node is uniquely identified by its host, its IP, and a unique ID that's generated as when the node starts up. So even if a node starts up again on the same host and port, it's going to get a new unique ID when it does it starts up the actor system fresh from the beginning again.
Okay. Well, I definitely look forward to helping you produce the next project, which includes split brain resolver, and would give a little bit deeper insight into what happens when you have a true network partition and all of these scenarios that can come up. So Hugh, I got to say there was a lot of excellent feedback that this was a very useful demo. People are feeling more inspired to explain Akka Cluster to some of their colleagues who might be wondering what exactly it is.
Fantastic.
So thank you very much for this demo today. It was fun to go through some of the scenarios. People will be able to find you on Twitter if they have some questions about the demo. We have already got some feedback from one of our audience members, so he's going to be emailing that to us.
Great.
And I hope everybody had a good time today. We look forward to doing another one of these interactive sessions when we can. So stay tuned. And thanks everyone for coming out. Thanks again to you, Hugh.
My pleasure, as always.
All right. Bye-bye, everyone. See you next time.